Hello, everyone, and thank you for coming to today's presentation. The title of this presentation is Why a Major Japanese Financial Institution Chose Databricks to Accelerate its Data and AI-Driven Journey. I'm Yuki Saito from NTT DATA. I work as a cloud architect and data engineer. I am involved in the development of data platforms. I also the first Databricks champion in Japan. In addition, I am a certified top engineer for AWS in Japan's region. And therefore, I have a strong edge in the area of data utilization using cloud services. Here is today's agenda. Today, I'd like to introduce a case study of a Japanese financial institution. I hope this session will be helpful to those who are considering implementing or proposing Databricks. My presentation is divided into 3 parts. I'll start with talking about NTT DATA and our solution. Then I will explain the case study. The case study begins with an overview of the project, explaining why Databricks was a candidate for architecture product selection, the points that were evaluated in the POC, the challenges in implementation, and the effects of data lakehouse architecture. I will then conclude with a summary. We will have a Q&A session after the presentation. If that's okay, let's move on to the next slide. First, I will introduce NTT DATA and our solution. NTT DATA is the 6th leading IT service company in the world. We are a leading company in the Japanese market with a wide variety of customers. We mainly develop systems and provide IT services based on our customers' requirements. So the NTT DATA Group comprises of an organization that encompasses 203 cities in 53 countries and regions, and approximately 151,000 people, and is reinforcing its ability to provide support for global companies. Next, I will explain the status of data utilization in Japan. Many companies have implemented data platforms and are at the stage of gaining insight through data visualization using DWH-BI. However, according to statistics from Japan's independent administrative institutions, only a few companies are implementing advanced data analysis using AI, leaving them far behind US companies. Therefore, we at NTT DATA believe that our mission is to raise the maturity level of data utilization by using AI utilization to fill this gap. To achieve this mission, we offer the Trusted Data Foundation, a cloud-based big data analysis platforms that facilitates data utilization. And we have launched Trusted Data Foundation powered by Databricks to further democratize data and AI. Let's take a look at the Trusted Data Foundation. The system is built on AWS and consists of a data lake where data is collected and organized, and the data lab, which is an environment for data analysis. Let's take a closer look. The data lake on the left collects various internal and external data. It processes and converts it into from easy for users to analyze, and then stores it. It also has a data catalog functions so that analysts can easily find what they need from a huge amount of data. After that, Data Lab on the right is an environment for analyzing data, with departmental installation of different tools for different kinds of analysis. including BI, AI development, and statistical analysis. From here, I will begin to introduce the case study. First, I will introduce an overview of the project. Our client is a major financial institution in Japan and a pioneer of data utilization. We have been building a data analysis platform since around 2017 with the aim of developing new products and services and digitizing business processes. As a financial institution, we have strict security requirements because we handle PII. Since this platform is a company-wide platform, it needs to accommodate a variety of use cases. After 5 years of operation, we have grown into one of the largest data analysis platforms in Japan. The current system architecture looked like this. Basically, the architecture follows AWS best practices. Data is stored in S3 and processed by distributed processing technologies such as EMR and Glue. Ad hoc analysis and BI are then performed by throwing query to Athena or Redshift, RDS. We also make AI models in SageMaker for AI ML use cases. Now, let me explain how this system is used. When it was first built, BI was main focus. And we use BI to visualize KPIs and business situations. Now, AI ML use cases have increased. We are converting operations that used to be based on the rules to AI. In some analytical environments, advanced analysis, such as deep learning and Monte Carlo simulation, has also begun. The data analysis platform I've described so far started out small like this. From a company-wide environment with data and tools in place, the number of users has increased every year. And we have grown into a large-scale environment. Now, the range of use extends beyond the entire company, such as including group companies and contractors. However, not everything has gone smoothly. The more users, data, and use cases we had, the more problems we found. The other side of growth of our data analysis platform has been dealing with these problems. As you can imagine, an increase in users has led to increase in infrastructure costs. And an increase in data has led to a lack of resources. Also, when we started machine learning, we had problems such as our work lacking governance and not knowing how to proceed towards AI. The industry was moving so fast that systems were not able to keep up with the latest technologies, and there were situations where useful features are not yet available. In addition, there are situations such as when the number of servers exceeds 100, where even with the use of automation technologies, it tended to take longer. In order to resolve these issues, as we have just reached the 5-year milestone, we decided to fundamentally review the architecture. In reviewing the architecture, we compiled a vision of the future data analysis platform based on the current issues and requests. We have grouped the issues and requests into the 6 categories shown here. The categories on the left are about business and analysis. expanding of data utilization, promoting advanced data analysis, including AI development, advanced data analysis, accelerating business application of analytic results. On the right are categories about systems, extending security and governance, improving operational efficiency, and optimizing cost. We evaluated new platforms using these categories. So we selected several candidates for data platforms and AI platforms that can realize the next generation data analysis platform to use architecture patterns to realize BI and AI use cases, and evaluated the proposal that best fits the analysis use cases. The following POC was conducted for the leading architectures, including Databricks. After considering the degree of compatibility with the future vision in 6 major analysis use cases, and the number of issues resolved, the client selected the data lakehouse architecture. I will now explain in turn why Databricks was selected as a candidate for evaluation, the points on which Databricks was evaluated, the challenges encountered in implementation, and the effect of implementing Lakehouse architecture. Next, I will explain why Databricks was selected as a candidate for architecture evaluation. Although Databricks was not well known in Japan in 2021, NTT DATA began researching the technology in 2019 and found it effective for the following points, which will be major challenges for AI and unstructured data utilization in the future. Based on our experience in developing data analysis platforms for over 5 years, we found Databricks Lakehouse architecture to be particularly effective in addressing the challenges in the current DWG-based data analysis platforms. I will now explain the reasons for this, including the actual issues that arose. As was true in this case, common data analysis platforms are often centered on Athena, Redshift, BigQuery, and other engines that process large data in SQL. The BI use case involves throwing queries to a large SQL engine and returning the result to the client, which works well. However, consider one thing. Can machine learning be executed with SQL? In general, the answer is no. Machine learning deals with the files, not the tables. Therefore, large SQL engines are not optimal for AI/ML use cases. Machine learning library inputs are files, so you cannot directly reference the database. So the analyst needs to download the data. There are reasonably common cases where this data can be hundreds of gigabytes. Due to the large size of the data, downloads take longer, and local disk shortages often occur. Then we do feature engineering, which is pre-processing of machine learning. Some of this processing is difficult to do in SQL. So it's usually done in Python. It runs on the local server, so it often runs out of local resources. It also requires more disk to store the processed data. Then there is a learning processing, the work of making AI models. We do a lot of data over and over, and then repeat the calculation until the parameters are determined. So we often run out of resources on the local machines. Insufficient resources often led to processing being unfinished for several days. As you can see, none of the secret engine we have prepared are used. The processing of machine learning is done on the local server using Python because the secret engine cannot run it. This results in the problems we've discussed. The client in this case study had a problem with the unusually high cost of AI/ML environments. Also, it is difficult to manage how data downloaded locally is processed. As a result, the ability to reproduce AI models decreases. No matter how good an AI model is, if it's made with such uncertain data, commercial use will be difficult. We considered how to solve these problems. We thought a good model would be one like BI, where Python processing happened on the server side without moving data. For that, we need the largest Python engine. In general, Apache Spark is often used here. So, is it better to use both a large SQL engine and a large Python engine? In the end, the increase of cost of having duplicate data too high, as well as the reduced usability of different tools. Therefore, Databricks, which combine both engines, came up with a proposal. Thinking it would be the best solution as an analysis platform for BI and AI. Next, I will introduce a point on which Databricks was evaluated. We evaluated Databricks from a variety of perspectives. In this time, we will discuss 8 typical evaluation points. First is the use case for BI and ad hoc analysis. Typical workloads were run on the Photon engine and evaluated for high-speed data processing. In addition, usability, such as whether the data can be handled easily from the data analyst's perspective, is evaluated. In data processing, there were concerns about whether the performance would be sufficient compared to pure DWH products. Now, let's look at the details. First, we checked to see if we could connect from Tableau, the BI tool used by our client. Databricks supports connections from major BI tools, so we were able to connect from Tableau without any problems. Next, we calculated the query processing time for typical workloads and found that we could expect a performance improvement of about 3 times versus cost. Therefore, we concluded that Databricks is comparable in performance to a pure DWH. Finally, we asked the user to interact with the screen to check usability. Since usability from BI tool does not change from one engine to another, we focused on the operation that converts data into tables. As a result, users found it easy to use because of its low data loading cost, omission of type definition by inferring the schema, and the fact that the operation can be done in a few clicks. Contrary to our concerns, the processing time was comparable to that of DWH products. And the system was able to meet the level of user requirements. The usability of the system has also well received for its ease of understanding. And we expect to improve the efficiency of our analysis operations. Next is the use case for AI development and ML ops. AI development and ML ops were also evaluated the completeness of functionality and usability based on actual use cases. Since AI development involves many issues from infrastructure perspectives, security and cost were also evaluated. Let's look at them one at a time. First, we confirmed that comprehensive ML ops functionality is available, including the experiment management and model management functions that we currently use. ML Flow has a wide variety of ML ops features and covers the functionality we needed. We also found ML Flow fully integrated into the Databricks UI, making it easier to use. And the current service did not have a data version control function, so we had to create a prefix each time and store the data in S3. Delta Lake's data version control feature is expected to improve governance and reduce costs. Next, we confirmed with the data scientists that Databricks is easy to use according to actual use cases. As a result, compared to current services that require knowledge of cloud services and containers, Databricks was well received as easy to use with just Python knowledge. The ease of migrating notebooks that have been developed on local machine was also appreciated. Next, in response to the desire to increase the freedom of data scientists, we checked to see if they could perform operations that users are not allowed to perform from a security and governance standpoint. Databricks' advanced access control at the application layer enable access controls that had been difficult to achieve at the cloud layer, allowing data scientists to perform more operations that they could perform themselves. This will greatly increase the work efficiency of data scientists. Here is the infrastructure perspectives. First is security. We checked if the detailed access control by RBAC that is implemented in the current services is possible. And we found that the current access control is possible with Databricks without any problems. After that, we checked if it is possible to record individual operations on the data as audit logs. Currently, we use a combination of cloud logs and OS logs, but we were able to confirm that single Databricks logs is sufficient to obtain this information. Finally, we checked to see if the data could be used in BI and AI without copying and to reduce the data duplication. Databricks stores data in an open format, so the same data can be accessed from SQL and Python. Snapshots of data are also automatically retrieved by Data Lake's time travel features. These have proven to prevent duplication of data in many cases. So, Databricks data scientists have greater agility in AI development with easier self-service access to a wealth of functionality. Also, administrators can reduce the operational burden of ensuring security, as well as the cost and management burden of duplicate data. There are many more other things to appreciate about Databricks with regard to data engineering, such as the ease of handling unstructured data and the easy visualization of platform usage on the dashboard. But due to limited time, we will unfortunately omit them. Next, I would like to move from the main topic, and I talk about the challenges we had when implementing Databricks. In the current climate, security requirements were strict and multi-factor authentication was a must. Therefore, source IP restrictions were required during authentication. As you all know, Databricks has two interfaces: Workspace, the user interface, and Account Console, the administrator interface. The Workspace interface allowed source IP restriction, while the Account Console did not at that time. We investigated and concluded that SSO from a closed environment would be equivalent to the source IP restriction. However, during the POC phase, we realized that the Account Console API was not SSO capable. Since this was not mentioned in the documentation, so we were not aware of it beforehand. As it was, Databricks was no longer a candidate. Since the NTT DATA team are also AWS specialists, the following tentative proposal was developed within a few days to ensure that Databricks remained a candidate. To avoid compromising security, we implemented the AWS Lambda function. Lambda was implemented to monitor Account Console configuration differences in near real time, and revoke IAM privileges delegated to Databricks when an unauthorized connection or configuration change was detected. As a full-scale response, Databricks released the ability to restrict the IP from which the Account Console connects in April. This episode shows how well the NTT Data and the Databricks teams worked together to meet the client's requirements. Let's move on to the next episode. The expansion of machine learning has created a demand for both table-based and path-based access control to files. However, the current access control privileges in S3 are rigid and can only be modified by administrators. This limitation has led to decreased usability for data stewards and data scientists, as they are unable to easily manage the file access control. Unity Catalog enables access controlled by grant and revoke for paths, as well as a table access control for location objects, which is corresponding to paths under the S3 access control. The Unity Catalog improves the usability, but at the time of the POC, it was in the private preview stage and had not been tested in Japan. So frankly, it was a very difficult decision, but we decided to implement it through careful testing because we were convinced that it would greatly improve our clients' issues and that it would truly represent Lakehouse and would definitely become a core function in the future. Fortunately, there are no major defects, and the effects described here were achieved. Catalog enables us to unify different access control models for each BI and AI use cases, lowering management costs and improving usability. The company was able to immediately benefit from the new features premised on the Unity catalogs. Through this experience, we believe that we should actively use the latest feature to keep up with the rapid progress of Databricks. Next, I will introduce the effects of data lakehouse architecture. Many challenges were resolved by Databricks. As for increased costs, many workloads will be pay-as-you-go, which is expected to reduce cost by 60% from the current level. Regarding lack of resources, Scalable computing resources can now be used without moving data. For lack of governance and efficiency in machine learning, MLflow has made available a wealth of MLOps capabilities without additional configurations. As for delays in providing the analysis environment, we expected a 30% reduction in workload compared to in the past. Because analysis tenant can be easily dispensed within the unit of Workspace. And there are many other positive effects on the introduction like this. It was effective in a variety of areas, easier handling of unstructured data as a table, improved usability, security, and reduced migration costs. To conclude my presentation, I would like to summarize now. Our client is a major Japanese financial institution. They are trying to focus on AI development as well as BI. The TWH-based data analysis platform has encountered a number of challenges related to AI development, such as slowing processing, lack of resources, lack of governance, and so on. The clients then chose Databricks as their next-generation data analysis platform because Databricks is one of the best solutions for BI and AI. Here is a reason for client's evaluation. For BI and ad hoc analysis, functions and performance comparable to pure DWH products. For AI development and ML ops, increased agility in AI development. For system infrastructure, advanced security, cost optimization, and reduction of operational load. As in this case study, NTT DATA will promote democratization of data and AI with Databricks and Data Lakehouse. I hope this case study will be useful for clients who aim to utilize AI and partners who have the same mission.